everyone. Okay, so in this video, we are talking about complex numbers and an introduction to imaginary numbers. So the easiest way to introduce complex numbers is with this quadratic equation right here. So many years ago, minds greater than eyes and greater than yours, they came across this quadratic and they're like, what are the solutions to this quadratic? So they did it out. So we use our minus b formula. We use the minus b formula here. So remember, minus b plus or minus square root of b squared minus 4ac all over 2a, where a in this case is 1, b is going to be minus 1, and c is going to be plus 1. So let's sub it in. So minus negative 1 plus or minus the square root of minus 1 squared minus 4 times 1 times 1 all over 2 times 1. So these are my two solutions to this quadratic equation. So let's simplify it now. Minus negative 1 is just 1. So 1 plus or minus square root of 1 minus 4 all over 2. Now, if you just put all of this into your calculator, you're going to get an error, right? And why do we get an error? Because look, when I simplify it down here, I'm going to get 1 is equal to, so x is equal to 1 plus or minus square root of 1 minus 4. That's negative 3 all over 2. What's happening? What is the issue here? Well, the issue here, to my keen-eyed viewer, is I have a negative underneath a square root symbol. And up until now, that was a mathematical no-no, right? So we are going to be learning about the square roots of negative numbers in this video. Right? So another thing to say about this quadratic is if you were to plot out this quadratic, for example, if you were to plot out this quadratic, this is a positive quadratic, so it's going to look like this. So this is my x-axis. If we plot that out, it's going to look like this. Notice how it does not, no, I'd say notice how it does, like I just made this up, right? This quadratic does not cross the x-axis here, right? So we say it doesn't have any real roots, or i.e., right, I'm going to have a complex root. So I'm going to show you now how we get rid of this minus, this root negative 3 here. So roots of negative numbers. So we know that when any number is squared, the result is positive. However, we may have to solve problems that result in the square root of negative numbers, e.g. square root of minus 1. So to do this, we introduce a new number called I, which is said to be imaginary. So we let the square root of minus 1 equal 2i. And that is all we need to do for this video. So that means, therefore, I squared is going to be equal to minus 1. So just to recap there, we introduce this new variable, well, not new variable, this new kind of number called I. That is equal to the square root of minus 1. And when we square that, we're going to have root minus 1 times root minus 1, which gives me to, when I multiply two things in the same square root, it's cancel square roots, minus 1. So I squared is equal to root 1. Okay, you might be asking yourself, okay, what's that have anything to do with this root minus 3 we had earlier? So we're going to be using our rules of surds here. So remember, if I multiply two things in a square root together, I multiply them underneath the same square root. So let's split this up. I can rewrite square root of negative 16 as root 16 times root minus 1, right? Because I can write that as root 16 times minus 1. Using the rule up here, I can say that's equal to root 16 times root minus 1, which is equal to 4 times, and now let root minus 1 be equal to I. So say that is equal to 4i, and there is my solution there. This one here, root minus 144, that's the same as root minus 144. So root 144 times minus 1, which is equal to root 144 times root minus 1, which is equal to 12 times I, which is 12I. Root negative 8, that's going to be root 8 times minus 1, which is equal to root 8 times root minus 1, which is equal to root 8. If you put that in your calculator, you are going to get 2 root 2, and then multiply that by I, which is equal to 2 root 2I. Finally, root minus 20, that's the same as 20 times minus 1 equals root 20 times root minus 1, which is equal to, put root 20 into your calculator, you are going to get 2 root 5 multiplied by I, because remember root minus 1 is I, which is equal to 2 root 5I, right? And that's all we need to know for this. So we just need to know how to be able to convert a root of a negative number into a number with an I in it. So just another thing we need to be aware of is the powers of I, right? So if we consider the powers of I, we notice a pattern here. So if we look at the pattern here, I to the power of 1 is just I to the power of 2 is minus 1, I to the power of 3 is minus I to the power of 4 is I. So if you want to, feel free to do that yourself. But I squared, we realize, is minus 1. I multiply by I. Minus 1 times I is minus I. Multiply by I again. That would be minus I times I, which would be minus negative 1, which is going to be positive 1. And then we repeat the same process here. It's very cyclical, right? So every 4 terms we go back. It's I minus 1 minus I 1. I minus 1 minus I 1. Right? Every 4 terms it's cyclical. We notice a pattern. So the values repeat in sets of 4. If we're asked to simplify a large power of I, we divide the power by 4 and note the remainder. So if the remainder is 0, right, it's going to be equal to 1. If the remainder is 1, it's equal to I. If the remainder is 2, it's equal to minus 1. And if the remainder is 3, it's equal to minus I. So that is only if we're given a power of I. So let's look at these examples here. So 10I, well, 10 divided by 4 is equal to 2 remainder 2. So I have a remainder 2. That means this is going to go to a minus 1. Here, I to the power of 35. 35 divided by 4 is 8 remainder 3, I believe. Remainder 3, this all goes to minus I. Then root I to the power of 72. That's going to be 72 divided by 4 is I'm pretty sure that divides in even. Let me just double check. I think it goes like 18 times. 72 divided by 4. Oh, ate that, right. 74 divided by 10 is 18, remainder 0. So since I have a remainder 0, my answer is 1. So you just need to notice them patterns like that. So in your exam, if you ever asked that, write down the first 4 pairs of I by yourself by hand. You know I is equal to root minus 1. I is I multiply by minus 1 and just do that up to get to the power of 4, and then we have enough information to answer these questions. Right, so let's look at these ones here. Simplify the following. So I to the power of 6, so 6 divided by 4, well, that's going to give me 1 remainder 2. If it's a remainder 2, I have minus 1. So the first one here is going to go to minus 1. Here at 38, so I to the power of 38, 38 divided by 4 gives me, I'll tell you right now, 9 remainder 2. And again, it's the remainder 2 here, so my answer is going to be minus 1. Part 3, 5i root to the power of 27 plus 6i to the power of 13. Well, let's simplify these. So 5i to the 27, that is going to be equal to 27 divided by 4. So let's find out what this I goes to. So 27 divided by 4 is going to give me 6 remainder 3. So therefore, that means if remainder 3, that I to the power of 27 is going to go to minus I. So 5 times minus I, then minus 3 times, so this I to the power of 57, that is going to go to 57 divided by 4. That is going to give me 14 remainder 1, and so we have a remainder 1 that means it goes to I. That goes to I there. So it's going to be minus 5I minus 3I. And we'll learn later, but we could just add and subtract these. This is going to be minus 8I. Right? IV. Oh, I did the wrong one. Oh, I did the wrong one, but you get the point anyway. Right? So it's actually a 6 in here. Ah, you get the point. I'm not editing this out. Right. So 6 times, okay. 13 divided by 4 is equal to, yeah, so it's got to be 13 divided by 4. 3, remainder 1. It's a remainder 1, so we're going to I. Remainder 1, so we're going to I. Then that's minus 5I minus 6I, which is going to be minus 11I. Right? Then I feel like I don't really need to do the rest of them, but I'll do them anyway. So IV, so I have 10 to the I to the power of 36 minus 3I to the power of 57. Well, 36 divided by 4 is 4 remainder 0, so I have a remainder 0. This I term is going to go to 1. Right? Minus 3 times, well, I to the power of 57, well, we knew that one there because I did a mistake. 57 divided by 4. That's going to give me 14 remainder 1. And then remainder 1 gives me, go back up to a little table here, remainder 1 gives me I. So I have 10 minus 3I, and that is all I can do for the time being. And finally, the last one here, part V. I to the power of 19 to the power of 6. Well, we know from indices power to a power, we multiply. So that's going to be I to the power of 29 times 6. Oh, 19. 19 to the power of 6. So that's going to give me I to the power of 114. Divide that by 4. I'm going to get 28 remainder 2. I have a remainder 2 here. And again, you go to your little table here. And that goes to minus 1. So this whole thing will develop down to minus 1. Right, okay. Let's look at some Leaving Cert or level questions now. So this is from the 2016 paper. Write in the simplest form. I times I to the power of 4 plus I to the power of 5 plus I to the power of 6. So we can just simplify in here. Or I know it's going to be I to the power of 5. So I'm multiplying this I in. Plus I to the power of 6. Plus I to the power of 7. So I to the power of 5. So 5 divided by 4 is 1 remainder 1. I have a remainder 1. So my answer here is going to be I. So this term is going to I plus 6I. 6 divided by 4 is 1 remainder 2. So that's remainder 2. You go up and you check your little table you drew out. It's minus 1. Just minus 1. And then I to the 7. 7 divided by 4 is 1 remainder 3. And that is going to be equal to remainder 3. My answer is just minus I. So I plus minus 1 minus I. Well, I minus I, they cancel out. So I have minus 1. That's it. Right. 2003, paper 1, question 4a. Given that I squared is equal to minus 1, find the value of I to the power of 8 and I think that was actually meant to be like I to the power of 7 or something, but we'll just do the first part. So this came up in 2003, like 20 years ago, so it's like, it hasn't come up in a while. I to the power of 8, so 8 divided by 4 is equal to 2, remainder 0. If it has a remainder 0, that means this just goes to 1. It goes to positive 1, and that is my answer. Right. So that's our intro to complex numbers, and finding roots of negative numbers and powers of I hope this video was some help, and I'll catch you guys later. Bye.